Okay, today we talk about the net change theorem, and it's not going to look a whole lot different, but there's something important that we're going to reference. Okay, we're going to look at the integral from a to b of f of t dt, and instead of writing f of t, I'm going to write this as the integral from a to b of big F prime of t dt. Everybody agree that those are equivalent? That the derivative of big F will give you little f? So therefore, what's really important is that this is a rate. So the net change theorem has to do with rates. When you're given a rate function, we get in this situation f of b minus f of a. And this will give us what I refer to as accumulation. That whole chunk. So for example, every day I encounter a specific rate. I encounter a rate which is the speed of my car. Okay? So if I take the integral from a to b of a velocity function, velocity is a derivative, right? What do you take the derivative of to get velocity? Speed and velocity are almost interchangeable. Speed is just the absolute value of the velocity. What'd you say? Acceleration is actually the derivative of velocity. Do you remember that we started out? Yeah, position. So we had s of t, we had v of t, and we had a of t. We took the derivative of position to get velocity, took the derivative of velocity to get acceleration. So when you take the antiderivative, you get the position at time b minus the position at time a, and it will tell you the displacement of the actual object. Do you remember first semester when we said how far has the object traveled over the course of the first 8 seconds? The particle. And so we had to look at all the different changes in directions and everything, right? We're going to show you ways to work through that that's a little bit simpler. It's easier if you use integrals. So we look at the first example. We're just going to work through this front side today. I'm going to redo the notes for tomorrow because I really don't like them. We're going to make a worksheet for you. Particle moves at velocity modeled by the function v of t equals t squared minus 6t minus 6, where t is measured in seconds and v is measured in meters per second. I'm going to start out by making a graph of that function. I know it goes through -6 down here. And if I look at the velocity function, I can factor it. And it factors to t minus 3 and t plus 2. So it crosses the x-axis at -2 and at +3. Is everybody okay with that? That's the velocity function, okay? Now you tell me something interesting about the velocity right here. It's negative. Tell me something interesting about the velocity here. Are you sure it's positive? The velocity is positive here because I'm sitting above the x-axis, right? The acceleration is negative. The derivative of velocity is negative, okay? So velocity is positive, velocity is negative. What does it mean for the velocity to be negative? Yeah, I'm traveling in the other direction, okay? So here's what we're trying to figure out, okay? Let's say it's 12 feet to the door, okay? I walk the door, and I walk back. What is my total displacement? What is my total distance? See that? 24 traveled, total distance. Displacement is 0. Exactly. So you can see in this situation, what it's wondering is it says find the net change or the displacement over the interval from 1 to 4. Well, that can be represented simply by the integral looking at the area. If I take the antiderivative of velocity, I get position. So the first part accounts for a negative distance traveled, and then the part to the right that's above the x-axis accounts for the positive distance traveled. And so to find the displacement, I simply look at the integral from 1 to 4 of v of t dt. I promise you that you will use this direct piece on the AP exam. And so we're going to spend one day today, we're going to spend another day tomorrow, looking a little bit more in depth, and then before the AP exam, we're going to spend a lot of time on this. It's going to be very important. How do I evaluate that? What do I do? Take the antiderivative, right? What's the antiderivative? Right, and I'm going to evaluate that at 4 and at 1. I like to set it up in parentheses. 4 to the third is, get 64 thirds minus 16 over 2 is 8 minus 24. Minus, now I plug in 1. 1/3 minus a half minus 6. And part of the reason I like to set it up like this is, number one, you're most likely going to be allowed to use your calculator in this part of the test when you get the AP exam, but not necessarily. So if you want to evaluate this by hand, I look at the ways in which I'm least likely going to make mistakes. So I look at 64 thirds minus 1/3, and I get 63 thirds, which is 21. I have a minus 8, a minus 24. Those are gone. I'm going to have a plus 6. I'm going to have a plus 1/2. So, again, if you can't use your calculator, I think that's the way that you are least likely going to make a mistake. 21 minus 8 is 13. Minus 24 is negative 11. Plus 6. Negative 5 or negative 10 halves plus 1/2 is negative 9 halves, or negative 4.5. And the AP exam is going to want this. Number one, it wants your setup for your integral. So that counts as points, whether you set it up or not. If you don't write it down, they don't give you the point. They want to see the antiderivative. They want to see the correct answer. They don't want to see the label. If I'm looking at the total distance I've traveled, what is the label going to be in? Meters. So I'm negative 4.5 meters to the left of where I've started, or below where I've started, however it's being measured. Okay? Is everybody okay with that displacement piece? That is this idea that if I start here and I walk to the door and I come back, my displacement is 0. But my total distance was 24. When the total distance was 24, you took the absolute value of the distances I traveled, right? The first distance was 12. The second distance was negative 12. You counted both as positive. So in order to find total distance traveled, this is the other part that you will see on the AP exam. Whoop. Is we have the integral from 1 to 4 of the absolute value of v of t dt. So when we do the absolute value of v of t dt, what it will do is it will take this portion that sits below the x-axis here, and it will put it above. For example, if I draw the portion that's below the x-axis in green, I would get something like that, right? And it'll just simply push that on top, and so the green will be my newfound area. I'm going to show you how to do it by hand, and I'll show you how to do it using your calculator. So, doing it by hand, what I have to do is I have to consider the point at where it changes from positive to negative. Where does it change from accumulating negative to accumulating positive? For a value of 3. So what I do is I set up two integrals from 1 to 3 of v of t dt plus the integral from 3 to 4 of v of t dt. Now, which one of these is positive, which one is negative? First one's negative because you can see that it sits below the x-axis there. So therefore, you'll have to take the absolute value of that when you're done and then add it to this, which will already be positive. That will tell us the actual total distance traveled. Do you think the total distance will be more than 4.5 or less than 4.5? I would say it would probably be more. So in order that we can get through this a little bit more quickly, and you guys can have a little chance to participate here, we're going to draw the line right here. So everybody on this side, I want you to calculate the negative distance traveled. So work out the integral, plug in 1 and 3. Everybody on this side, please do the positive distance traveled. You guys take the antiderivative, plug in 4 and 3. Please try to not use your calculator. Verify with a partner to see if your answer is correct. Okay? Go ahead, take some time there. Okay, let's see what we've got here. What do you guys come up with for negative? Negative 22/3. So you're going to take the absolute value of that. Very good. And over here, so if I find a common denominator, I would be 6. So I would have 44, 6, plus 17, 6, which is 61/6, which is 10.16 repeating. And what is my label? Meters. You have to make sure that you put that in, okay? When we get back, we'll look at how to check that and verify that on your calculator pretty simply and give you 2 problems. Enjoy lunch. All right, so here we have it. We have 10.16 meters is going to be the distance. Negative 4.5 meters is the displacement. This is what you'll carry out in your assignment today. You will then check your answers. You will check your answers using this. Turn my calculator on. I go into y equals, and I type in x squared minus x minus 6. I could go second calculate, number 7. And my lower limit is 1, my upper limit is 4. And so it is going to mirror, as you can see, what we drew. I want to encourage you that you might ask yourself, do you actually have to draw the velocity graph? Well, technically no, but that might help you understand what the problem is asking for. Does this look like what I have here? Negative 4.5. So then as I go into y equals, in order to check the actual total distance, I insert an absolute value sign. And I find that by going to catalog is where I chose to go. And so we talked about flipping this upside down and looking at then the green as the positive area. And sure enough, that's exactly what the graph does, which is pretty cool. And if I calculate number 7, again, I go from 1 to 4, and it starts pulling there. And your calculator does do an approximation. As you can see, we know the exact area is 10.16 repeating. It comes out to 10.167. The AP exam, the graders will account for that. They would have you round it to the nearest 100th anyways, or truncate, and you should be at 10.167 10.166 or 10.167. So are you clear what you're supposed to do for your assignment today? Please do it all by hand and then verify using this operation on your calculator. We will be building on this moving forward. And when I say it's for the AP exam, you'll be tested on it as well. You have a test before the AP exam to make sure that you're preparing for the exam as we do in class. So your assignment is right here, just 2 problems. We will build off of it tomorrow. Although I used most everything from last year because I was pretty happy, this is one section that I'm redoing, so I need to rewrite the notes. I'm just not happy with them, and I'm not happy with the assignment for tomorrow, so I need to redo that. So